Hi, I'm Chem's best friend. I make chemistry easy. I'm a graduate of MIT, and I have more than 17 years of experience teaching AP chemistry and chemistry classes. Please like and subscribe to my channel. And if you are interested in private tutoring lessons, the information is on the screen. Hi, now that you know the five types of chemical reactions and why they happen, I think it's time to practice. I think it's time to practice to predict the products. So let's go to my screen and practice. We're going to go through a lot, and I think you should have your periodic table ready, as well as solubility rules and activity series to help us predict the products of these reactions. Okay, let's start. So first, we're going to look at reaction number 1. Let's look at our reactants and what type of reaction it might be, where we have an ionic compound reacting with another ionic compound. So this one is my double replacement reaction. And it is not redox. So my two cations, right, will switch places. And I'm going to have, what am I going to have? I'm going to have calcium carbonate plus sodium hydroxide. And I have to now look at my charges to make sure that my new compounds are neutral. Calcium is +2, carbonate -2, that's great. And then sodium +1, hydroxide -1, that's great. And I have to quickly look at my solubility rules. I know sodium hydroxide is AQ. And I'm going to look quickly here. And we have our carbonates. So what's going on? Carbonates are insoluble except with sodium, potassium, and ammonium. So that means that this one will be our solid. And that's chalk. Chalk is insoluble in water. Let's go forward. This type of reaction, number 2, well, what's going on? Copper is by itself. So copper might switch with another metal ion. So let's see if copper and silver, will they switch? How do we check? Do you remember what we did? We're going to look at our activity series. And here we go. Here is copper. Here is silver. Copper is above silver. Copper wants to be ionic. Silver is on the bottom. It doesn't lose its electrons that easy. So silver will prefer to be neutral, to hold on to its electrons. So therefore, let's see, will this reaction happen? Yes, this reaction will happen. So we will have copper nitrate plus silver metal. Oh, I didn't balance this one quickly. Silver metal, nitrates, everything with nitrates is aqueous. And I have to make sure I balance this one. I have 2 nitrates. I need to have 2 nitrates and then 2 silvers. So yes, there we go. My balanced reaction. It is our single replacement reaction. I'm going to put single replacement, and it is redox. That's the driving force for this reaction. Let's go to this reaction. What's going on here? We have a carbon-containing compound. This is ethanol. You'll be burning ethanol. So this is ethanol reacting with oxygen. What type of reaction? Well, carbon-containing compound reacting with oxygen is our combustion reaction. Combustion reaction, it is redox. So let's predict our products. For combustion reactions, it's going to be what? Carbon dioxide plus water. And I'm going to put gas in here because it's very hot, it's burning. So we have to quickly balance it. So we have 2 carbons, 2 carbons. We have 6 hydrogens, and let's check my oxygens. I'm going to have 6, 7 here, and I need 3 over here. So now my reaction is nicely balanced. My states are all correct. I'm good. Let's go. Another one quickly. Okay, we have fluorine by itself. So fluorine might switch with another nonmetal. Remember, this was our halogens. Halogens, and so this is a single replacement reaction, redox. And now we have to quickly look at our periodic table. And fluorine is above chlorine on a periodic table. Do you remember your halogens? Fluorine is on top. And that means fluorine wants to gain electrons. It wants to gain electrons more than chlorine. So fluorine is more reactive. It will want to be ionic. So this reaction, yes, this will happen. So potassium fluoride, this will be that AQ. Plus, we're going to have chlorine gas. And we need to quickly balance it. So this will be 2, and this will be 2. There we go. And let's go to next one. What's going on here? We have 2 ionic compounds. So we have iron and hydrogen, and they switch places. So now look at this. Iron 2 hydroxide is not soluble. But if you put it in acid, you can make it soluble because double replacement reaction will happen. What will happen? Well, I'm going to form, I see HOH. HOH is water. So this has to be 2 to help me. And plus, it will be iron 2 chloride. And I know my chlorides are soluble except with heavy metals, which is our mercury, silver, or lead. And this is iron, so this is AQ. And I need to balance this. So here we go. This is now balanced. So this is our double replacement reaction. Okay. And really fast, if we're going to look what's oxidized, what's reduced, really fast to go through this. This may copper here became from neutral to positive, so copper lost electrons, oxidized, silver gained, reduced. We said oxygen gained electrons, reduced, and it's carbon that's oxidized. Here we have chlorine that's negative, and now it became neutral. So chlorine, negative, neutral, lost electrons, oxidized, and fluorine is neutral, gained electrons, reduced. Yes, and here double replacement reactions, remember, are never redox. So they are never redox. Let's keep going. Let's practice. If you would like, you can pause the video, predict the products, and see what you get. So let's keep going. Our reaction number 6. We have our double replacement acid base. Look, here's my acid, and then hydroxide is the base, right? So we have acid base. So we have our double replacement, and this is our acid base reaction. So they will form water. So they're going to form water. Plus, I will have potassium phosphate. And I need to balance this. I need 3 potassiums. I desperately screams to balance this for 3. And this will be my aqueous. So we have our double replacement reaction. Okay, so here we have just one compound. And if we have one compound, we have our lead 4 oxide. You say, decomposition. Yes, but it will not just be lead and oxygen. So lead is 4 plus. It's not going to gain 4 electrons all at once. So it first will gain 2. So we will have lead 2 oxide plus oxygen. Now, if I give you this reaction, this one, you will have lead solid plus oxygen gas. So it's a decomposition, and it is redox. And we need to balance it quickly. So I think we need 2 here, and I need 2 here. So I have 2 lead, 4 oxygens, and it's balanced. And this guy, I will need, if I have quickly 2 here, 2 oxygens, I will need 2 lead. There we go. So we have our balanced reaction, and it's redox. We can quickly go what's oxidized, what's reduced. Well, lead went from 4 plus to 2 plus, so it had to gain, is reduced. And oxygen went from -2 to right here is neutral, so it lost its electrons. It's oxidized. Okay, let's keep going. So we have, what's going on here? 2 ionic compounds. We have our double replacement reaction, yes? Let's go quickly. What's going on? We will have iron to carbonate, and then we will have sodium chloride. Is sodium chloride soluble? Is it? Do you need solubility rules? Do you live on the east or west coast? Do you live next to an ocean? That's salty, right? So sodium chloride is AQ. We need 2 of them to balance. Here we go. And this guy, carbonates are not soluble. So this will be my solid. So it's my double replacement reaction. Let's keep going. Magnesium reacting with hydrochloric acid. Okay, this reaction is my single replacement reaction. It is redox. Magnesium changes places with hydrogen. And what are we going to have? Well, we're going to have hydrogen gas, diatomic, plus magnesium chloride. That's AQ. And we need to balance this reaction. 2 over here. There we go. Let's keep going. Let's keep going. Okay. We have chlorine here. Well, it might switch places with iodine. Let's think about this. Our halogen, single replacement reaction. Single replacement reaction, redox for halogens. Let's think. Chlorine is above iodine. Iodine is on a bottom under, so that means iodine wants to be neutral, and chlorine wants to gain electrons more. Chlorine wants to be ionic. So yes, they will switch places. So it's going to be K, potassium chloride, and that's AQ. Plus we're going to have I2. And this will be, a little bit of it will be the dissolved in water. You can put solid, you can put AQ. And we need to balance it. And this is redox. And if you quickly want to go back, what's oxidized, what's reduced for number 9 and 10, magnesium is here neutral. It becomes positive. So magnesium loses electrons, oxidized. Hydrogen gains, it becomes from positive to neutral, gains electrons, reduced. And here chlorine is neutral. It becomes negative charge, chloride. So it gains electrons, reduced. Iodine is negative, becomes neutral, loses electrons. Iodine is oxidized. You always need to have reduction, loss of electrons, and something has to gain electrons. Oh my gosh, how are you doing? How are you doing? Let's keep going. Here we have what's going on. Metal plus non-metal. This is our synthesis reaction. It is also redox because we will have an ionic compound forming. Yes, we will have sodium bromide +1 -1. Solid ionic compounds always solid, so we need to balance right there. Let's keep going. Oh, we have zinc reacting with copper sulfate. Okay, we have to quickly look at our activity series. Yes, where this reaction happened. Let's look at activity series. Here is zinc. Zinc is right here. Copper is right here. Copper is under zinc. That means copper does not like to lose electrons as much as zinc likes. Zinc likes to lose electrons much more easy. So, will they switch places? Yes. Zinc will want to be ionic. So we will have zinc sulfate plus copper solid. And we have to quickly figure out, this is balanced nicely. We have to quickly figure out our solubility rules. Here is our sulfates. And they are all soluble except with barium, lead, calcium, strontium. So this one will be AQ. All right, all right. Wow, what do we have here? We have formaldehyde reacting with oxygen. It's a carbon-containing compound, so this is my combustion reaction. Oh, this one quickly. Single replacement redox. Going really, really fast here. our combustion reaction, it is also redox. And what are we going to have? Well, combustion reaction, carbon dioxide gas plus water. And let's balance it. And actually it is balanced. And there we go. Okay, let's keep going first to do everything. Then we will quickly say what's oxidized, what's reduced. Here we have our ionic compound with ionic compound. So it looks like a double replacement to me, where aluminum and iron switch places. So this is my double replacement. It is not redox. And let's see if they will switch places. Well, I think, well, okay, we will have iron and iodide. That's AQ. Plus we will have aluminum will be with bromine. But that's AQ. So here is the thing. I have two AQs. If I drew this reaction, I would have my ions swimming in a beaker, separated all by themselves, before and after reaction. So this one is no reaction, nothing happened. No reaction here. I'm not forming a solid, I'm not forming a liquid, I'm not forming a gas. Okay, let's keep going. This reaction here, we have a metal and a non-metal. So what do we have? We have synthesis, redox. So zinc combines with nitrogen. Now zinc is 2 plus with a non-metal. So zinc 3N2. And this will be my solid. And I need to then quickly balance my reaction. Here it is. Okay, let's go back quickly for our redox reactions. What's oxidized, what's reduced? Let's go quickly. Sodium is neutral, then it became positive. So sodium lost electrons. Oxidized bromine is neutral, gained electrons, bromine reduced. Right here, zinc neutral became positive, lost electrons. Copper was positive, then it's neutral, gained electrons, reduced. Right here, oxygen became more negative, gained electrons, oxidized, and carbon is the one that's reduced. There is no reaction here, double replacement, never redox. And then zinc again, lost electrons, oxidized, nitrogen gained electrons, reduced. Last page, are you ready? Are you ready for the last page? We have copper 2 oxide, and it's the same thing when we had lead 4 oxide, right? So this is our decomposition reaction. It is redox. And first we're going to go to form copper 1 oxide. And oxygen gas. Yes. So again, let's go through it, then we will decide quickly what's redox, what's not. Let's go here. Oh, this looks like we have lithium, ionic compound, sodium by themselves. Maybe they can switch places. So this looks like single replacement, redox. Let's look. Well, I look, and lithium is on top. Lithium wants to be ionic. Lithium is right here on top. And sodium is under. So sodium, when preferred with lithium, sodium wants to be neutral. So for this one, lithium and sodium, nothing will happen. There will be no reaction here. It's a trick question, right? Okay, let's go here. Ooh, what's going on? I have something with my acid and my base. This is what's going on here? Double replacement, acid-base reaction. Yes, double replacement, acid-base reaction. So it's going to form water, right? And we will form 2 waters, plus we're going to form calcium sulfate. And you're going to quickly look, and we're going to see sulfates are soluble, but except with calcium. So what's going on here? This one was a very special type. It will form a solid. Okay, number 19, let's keep going. What do we have here? We have our ionic compound and we have bromine by itself. So maybe bromine and iodine might switch places. And again, look at our periodic table. Bromine is above iodine. So yes, they will switch places. Sodium, we will have sodium bromide. This will be AQ plus iodine by itself. This will also go through the water, and we're going to quickly balance it. So we have our, single replacement redox. Oh my gosh, that's so much. Two more. Can you hang on to this? Can you still go with me? Let's keep going. We have ionic compound. Two ionic compounds. Well, maybe barium and hydrogen switch places. Let's hear. So we have our double replacement, never redox, yes. So let's think about this. What's going on? So we have barium sulfate. Plus we're going to have HCl. This will be my AQ. This is 2, and this guy will be my solid. So this is a formation of a solid. We have our precipitate. And last but not least, we have, well, iron reacting with oxygen. That's our very simplified rusting reaction, yes. So we have our synthesis reaction, synthesis here, and it is redox. So what's going on here? We will have, it will form iron free oxide, and this will be solid. Okay, really fast, let's keep going. What was oxidized, what was reduced for our redox reactions? Well, here copper went from 2 plus to 1 plus. So copper had to then gain electrons. It was reduced. Oxygen was oxidized. It went from -2 to neutral. So it lost electrons. So here we have no reactions. The double replacement, never redox. Number 19, what's going on? Iodine was negative charge when it went to neutral, so it lost electrons. So it's oxidized, and bromine is neutral, gained electrons to become negatively charged, reduced. Okay, number 20, double replacement, never redox. And number 21, iron is neutral, became positive, so it lost electrons, iron became oxidized, and oxygen reduced. That's where the term oxidation reduction comes from. And let's quickly balance this reaction. We're going to put 2 here, 3 here, and 4 here. So, wow, that was a lot. We practiced. We learned how to predict products of reactions. And I hope you can do it all by yourself now. So thanks for watching.